Hello everyone, we're Team B0, AutoErasing. This semester, we worked on a project building an automatic eraser system that provides a virtual board for instructors in classroom settings with limited board space. Usually in a classroom, there are only a few boards, and instructors have to erase some content during the class. People then won't be able to bring back the erased content anymore for the rest of the class. Our team wants to address this problem by allowing the instructor to refer back to the erased content at a later time. Therefore, we designed a board erasing system where the product automatically erases the board, captures images of the erased content before erasing it, and uploads the images to our web application, allowing all enrolled students and instructors of the course to view the images immediately. In addition, we also provide instructors with the ability to project the images back to the board. And with the projected content, the instructors can then annotate on previously erased equations and graphs and capture an image of the combined new content before erasing the board next time. Without further ado, let's take a look at our project summary. Here's a picture of the physical attachments on our whiteboard. We can see that the main source of control is the Raspberry Pi 4. It receives instruction from our web application to move the motor at a specified width and speed. The motor driver helps to convert the output signal from Raspberry Pi 4 to the input signal into the non-captive stepper motor. The non-captive stepper motor then rotates according to the instruction, moving along the screw rod. We've also included two linear slide guides so that the entire eraser system can move stably and smoothly. Next, here's a side view of the board setup with an IP camera and projector. The IP camera communicates with the web application to capture images of the content on the board and send it back to the web application immediately. The projector is used to project captured images back from a web application tab. Lastly, our web application is the main point of interaction between the entire system and the users, primarily the instructors. Note that students enrolled in the class can also log in and view the erased content. Instructors have the capability to modify classroom settings, such as which board the class is linked to and who gets access to the images. To erase some content and capture images, the only button the instructor needs to press is Erasing Board. This will trigger both image capturing and board erasing through HTTP communications between various devices. Now, let's look at an actual demo of the system. Logging in through Google OAuth, you can choose to be an instructor and create your own class and classroom board settings. To create a class, you need to specify the name, which board is linked to the class, and the ID of the enrolled students. Note that all authentication is handled by OAuth, so students can be found through their Android ID. Once you create the class, press Erasing Board button will let the IP camera take images of the erased content and immediately upload it to the web application. Now that we have the images uploaded, we can click on the image and view it in a zoomed-in version. Opening another tab in our web application allows us to display the image and press Erasing Board button at the same time. The students will also be able to enter the enrolled class and view the captured images. At the same time, our web application sends instruction to Raspberry Pi through HTTP request to erase the board. The Raspberry Pi, set to be the optimal speed through our experiment, then calculates the time it takes to erase the board of the widths specified by HTTP request from web application. The power consumption and speed of the motor movement were some major difficulties we encountered during the project. From our observation, the system works most stably without heating the motor driver at around 1.2 amps of current. When supplied with higher voltage or current, the motor driver usually heats up very quickly. Given that the datasheet says this motor driver can support 1.5 amps of current, we decided not to increase the limit anymore to keep a safer system. In addition, we've also experienced difficulties applying the correct amount of pressure on the board. To make sure we apply enough pressure to erase the content clean, we've added some hairbands between wood support of the erasers and the top slider block. We've also observed that too many hairbands usually cause the motor to stop in the middle of erasing, so we ended up using one hairband to balance the pressure and stability of the motor movement. After taking one picture and erasing the board, we now see a picture of a smiley face displayed in the projected content. Now, let's write some other content on the board again. Say, final demo. Going back to the web app instructor view, we can click on Erasing Board again and observe that the new picture contains both the smiley face and the text Final Demo. Note that this is achieved because the instructor can open a tab to display the images and another tab to control the erasing of the board. Therefore, with only one laptop and a projector, we helped the instructor to gain a lot more virtual space. In addition, our team has worked on thinking about the ethics of our product. We considered the safety of our users and decided to add some protection around the motor so that people don't accidentally hurt their hands. In building the entire system, we used wood blocks together with linear sliders to ensure the system is stable and reliable. Our website also has various techniques to protect against hacking, such as sanitizing the input and adding CSRF tokens. In summary, one of the most important lessons our team learned during the project is to always prepare for the changes and have backup plans. Since the proposal, we've pivoted the vision of our project 3 times, leading to a series of use cases and design changes. Moreover, the unexpected damage to the hardware components also slowed us down while building the system. With the ability to adapt to change more promptly, we could potentially overcome those technical challenges faster and incorporate more features as post-MVP. Lastly, we want to say a huge thank you to our TA Muken, our Professor Spyron, and Tamal for all of the help and support you all have provided us this semester.